Hello students, in previous lecture we have seen how to solve exact differential equations. Now in this lecture we will see what is integrating factor. So let us see definition of integrating factor. A differential equation which is not exact can be made exact by multiplying a suitable factor is called the integrating factor. So here, if given equation is not an exact differential equation, then we can made it exact by multiplying that equation some suitable factor, that means some function of x and y, so that the equation becomes exact differential equation. So that factor is called as integrating factor. So this is result about integrating factor, that differential equation m dx plus n dy is equal to 0 possesses an infinite number of integrating factors. So any differential equation, to make it exact, there may be infinitely many integrating factors. So integrating factor is not unique. Now we have to see that how to find integrating factor. So there is no any general rule for that, but here we have 4 rules for finding integrating factors. So rule first is integrating factor by inspection. That means only inspecting the given differential equation we can say what will be the factor which is to be multiplied or which is to be divided that equation, and then that equation will become exact differential equation. So here is one example. Solve y dx minus x dy plus 1 plus x square into dx plus x square sin y dy is equal to 0. Now this equation is not an exact differential equation. If we divide this equation by x square, then we get y dx minus x dy divided by x square, 1 plus dx 1 plus x square into dx divided by x square plus sin y divided by x square dy is equal to 0. So dividing by x square, we have written this by changing the sign, x dy minus y dx divided by x square. Here 1 plus x square, dividing by x square we get 1 upon x square plus 1 into dx plus sin y into dy. Here x square gets cancelled, x square into sin y, therefore here remains sin y only, sin y dy is equal to 0. So now this is, you see, this is nothing but derivative of y upon x. You take derivative y upon x by using rule of u upon v. So derivative of u upon v is v into derivative of u. So this is v x, this is u y. So x into derivative of y is dy minus y into derivative of x, it is dx. So this is nothing but derivative of y upon x, and this is pure term of x, and here is dx, so this we can integrate this term, and here also dy is here, and therefore sin y is on pure term containing y, so there is no problem for integration. So now integrating this equation is now integrable. So integrating, this is derivative of y upon x, therefore we get on integrating y upon x only. Here is minus sign already, and here 1 upon x square, integration of 1 upon x square is minus 1 upon x. Here integration of 1 means 1 dx is x, so this is x, and minus 1 upon x. Here sin y, integration of sin y is minus cos y, and therefore is equal to, here is 0, so we take constant of integration c. So we have integrated this equation, and now multiplying this equation by x, we get here minus y plus x square minus 1 minus x cos y. Here minus y plus x square minus 1 minus x cos y is equal to, here multiplying by x, c into x. So here by dividing x square equation we get the exact equation. This equation is integrable, means it is exact differential equation. We can solve it, we can integrate it, and so we have divided by x square, and so means multiplied by 1 upon x square, and therefore 1 upon x square is here integrating factor. So when there is a simple function, we can see, or we can conclude what will be the integrating factor. But for another function, there are second rule. If the given equation is homogeneous and mx plus ny is not equal to 0, then integrating factor is equal to 1 upon mx plus ny. So here if the equation is homogeneous, that means in the equation each term has degree same. See here example, solve x square y minus 2x y square dx minus x cube minus 3x square y dy is equal to 0. Now see here, the degree of each term is 3. Here x square y means degree of x is 2, degree of y is 1, so total degree of this term is 2 plus 1, that is 3. Similarly here degree of this term is 1 plus 2, that is 3. Here also degree of this term is 3. Here 3x square y, so degree of this term is 2 plus 1, 3. Therefore degree of each term is equal, therefore this is homogeneous differential equation. Now to find integrating factor 1 upon mx plus ny, first compare this equation with m dx plus n dy is equal to 0 and find out m and n. So comparing that equation, we have m is equal to this coefficient of dx, and n is equal to coefficient of dy. So calculate mx plus ny, x into m and plus y into n, mx plus ny. So multiplying m by x and multiplying n by y and taking addition, solving this, we get x square into y square, and this is not equal to 0. Therefore, by this rule, if the equation is homogeneous and mx plus ny is not equal to 0, then integrating factor is equal to 1 upon mx plus ny. Therefore, integrating factor is equal to 1 upon mx plus ny is equal to 1 upon, this is value of mx plus ny, x square y square. Therefore, this is a integrating factor. Now, to solve that differential equation, we have to multiply that given equation by integrating factor. So multiplying the above equation, equation 1, by 1 upon x square y square, we get this equation. Dividing by x square y square, here remains 1 upon y, here remains 2 upon x, here remains x upon y square, and here 3 upon y. So now to solve this equation, we have to integrate equation. Therefore, this is now exact differential equation, and we know the solution of exact differential equation is integrating m dx plus integrating those terms of n which do not contain x. Therefore, integrating m, here this is m now, and plus integrating n dy, those terms of n which not contain x. That term is minus 3 upon y, and here is minus sign, so here also minus sign. Therefore, integrating minus 3 upon y dy is equal to constant of integration, I have taken c dash. So integrating with respect to x, here 1 upon y is now constant. Therefore, 1 upon y dx, its integration is x upon y. Minus 2 upon x dx, integration with respect to x, 2 is constant. Therefore, 2 into 1 upon x, integral is log x. Therefore, 2 log x. Here minus minus, this is plus sign, and integral of 3 upon y, 3 is constant. Therefore, 3 into integral of 1 upon y is log y is equal to log c. Therefore, we have taken all these terms to the right side. Therefore, x upon y is equal to 2 log x minus 3 log y plus log c. So here you know the rules of logarithm. Therefore, this is nothing but log x square, and this is nothing but log y cube. Therefore, now here is subtraction of logarithm. We have taken this x upon y to right hand side, and here is subtraction of logarithm. Therefore, y cube divided by x square into c, log of y cube divided by x square into c is equal to x upon y. Eliminating this log, we get this y upon cx square is equal to e raised to x upon y. Therefore, y cube is equal to cx square, here is multiplied by cx square. So y cube is equal to cx square into e raised to x upon y. Here c is arbitrary constant, and this is a solution. So this is second rule of finding integrating factor and solving exact differential equation. Similarly, in next lecture we will see the integrating factor rule 3 and integrating factor rule 4. So you practice to solve the examples. Thank you.